We all watch TV, iron our clothes, heat water, drink cold water from the fridge. We do all that using electricity. But the question is, how do we make electricity? Or how is electricity made? Coming up is a teacher using digital science and virtual lab in a physics lesson, bringing you closer to alternating and direct currents.
Welcome to a Senior 4 physics lesson. For today, the topic is alternating current generators. The teacher, I am Patrick. The topic is alternating current generators. Why the topic? Why that topic? Imagine you are watching a soccer, world soccer on TV. And all of a sudden, when you are in the middle of the match, where your best team is playing, power goes off. How do you feel? Because you will not be in position to watch the TV again until something is done. Now, we need to know why we are learning about why we are teaching about alternating current generators. An alternating current generator transforms mechanical energy, majorly kinetic energy, into electrical energy. So that imagine if you are or your patient is being operated upon in a theater and there is no standby generator. That patient can lose his or her life. So we need an alternating current generator to be in place such that if the power goes off, it can be switched on so that we save the life of the patient. We have so many other appliances which use electricity, as we are going to see in the following animations. When you click on the first one, it shows you it's a toaster. The second one is a refrigerator. The third one is a computer. The fourth one is a fan. The next one is a flat iron. The next one is a hair dryer. The next one is a VCR. And then lastly, we have the washing machine. Now, all these machines need power. So that's why it is important that we don't rely only on the hydroelectric power, because if it goes off, we need an alternative source. And that is why we want to discuss about alternating current generators. Now we have another type. We don't have only alternating current, because there are some machines which use only alternating current, and there are those which use both alternating current and direct current. So if the hydroelectric electricity goes off, then we need the alternating current generator to be in place so that the machines can run as they have been doing. How does the alternating current generator produce electricity? First of all, let's look at the different parts. It is composed of a magnet. Let me explain why we need a magnet in the alternating current generator. Now, the magnet has got what we call field lines, and the field lines can be seen in the animation as seen in that diagram. We can get the field lines by using a magnetic compass. That is one of the ways of doing it. There are also other alternative ways. Now, when you look at the complete field lines around the magnet, they are moving from one end of the magnet to the other end of the magnet, specifically from the North Pole to the South Pole. That's where the arrows are pointing, from north to south. Now, when you have two magnets in between, you have a North Pole of a magnet and the South Pole of another magnet, and then you have a coil of wire in between. What happens? Now, let's first of all see how the field lines are in between the poles of the North Pole and the South Pole of two magnets. Right? You can see that the field lines are running from north to south. Now, another part of the apparatus that we need in the AC generator is the rectangular coil. The rectangular coil rotates in between these field lines, and it can only produce current, or current can only be induced into the coil when there is rotation of the coil in the field. That means the coil or the wire must be cutting the field lines. That is when there is induction of current into the coil. As I was saying, when the coil rotates in between the poles of a magnet, current is induced in the coil. And in order for us to establish the direction of the current, we need to use what we call Fleming's right-hand rule, as we are going to see in the following animation. Now, in this rule, the thumb represents the motion of the coil. The field is represented by the first finger, and the induced current is represented by the second finger. When those three are mutually placed at right angles, then the induction of the current will be done as long as the coil is moving and cutting the field lines. That is the concept that we are using there. Now, the AC generator is made up of the parts as shown in this animation. We said it has two poles of magnet, the North Pole and the South Pole. It also has a rectangular coil of wire in between the two poles. Then it has the slip rings in between them, and those slip rings are attached onto the carbon brushes. And then where you see that line, it is representing the position of the load, which may be either your TV, maybe your refrigerator, it may be your any other appliance which uses electricity. When the coil rotates in between the poles of the magnet, as we are going to see in this animation, for instance, now it is in the vertical position. Now, when it starts rotating clockwise, it begins to cut the field lines, as we are going to see, and we are making the number of magnetic lines to be maximum at 1,100. So when we start off, it now begins to cut the field lines. And as it cuts the field lines, as you can see in the graph below, the current is induced into the coil. That is half cycle. Then the next half cycle is when the current is moving in the opposite direction. And there you are, it completes now the second half cycle. Now we have seen how we can produce an alternating current using an alternating current generator. We are going to go for a short break, and when we come back, we shall use the same arrangement except for a few changes that we shall make. For example, we shall replace the slip rings with the commutators, so that we can see how we can produce the direct current.
It's impossible to see how electricity moves in a blackboard, but digital science and virtual lab makes it possible to understand how these currents work. You can follow us on Facebook and Twitter, CSTSUG. Hope you're loving the lesson. We'll be right back with more from that physics lesson.